In this video, we're going to use parametric equations in applications. And it says a cannonball is launched by a catapult with an initial velocity of 79 feet per second and an angle of 24 degrees to the horizontal. If the cannonball is launched with an initial height of 6 feet, what are the parametric equations for the cannonball's motion? So if it's launched at 6 feet, I'm going to assume that if this is the ground, we've got platform of some sort or just a person that's 6 feet high, and then we're firing this cannonball off of the platform with an angle of 24 degrees, and our speed is 79 feet per second. So that should be a visual of what's happening for this problem. Now, to write this, they want us to write this, the parametric equations. And there's a couple formulas for the parametric equations. So the parametric equations are going to be x sub t, so the x position with respect to time is going to equal VO, so velocity initial, and times cosine of t, times cosine theta times t. And then the y, so the position of y with respect to time, is going to equal negative 1/2 g t squared plus v of 0 sine theta, that's all in parentheses, t plus h. So let's write everything down we know. So h is going to be your initial height. V of 0, which is your initial velocity, is 79 feet per second. Because we're talking about feet, we know that gravity is, we're going to say 32 feet per second. So we can plug all this stuff in. Oh, and we know our theta, I should write that, theta is equal to 24 degrees. So basically we write down all our initial conditions and then we start plugging it into these formulas, and it'll show x of t is going to equal, this will be 79 cosine of 24 degrees t, and y of t would equal negative 1/2 times g, which is 32, and then we have t squared plus our initial velocity, which was 79, sine of 24, t, plus our initial height, which is 6. So we get y of t is equal to negative 16 t squared plus 79 sine 24 degrees t plus 6. So we're just taking our initial information and plug them into these two equations, and these two equations are what we would use for these launches, these flight patterns. You see that's the third option here, by the way. It's the third option.